Mother. Mm-hmm. So this is going to be a test. There seems to be an accident connection. And let me just start this. What is this? This is the presentation then. So welcome everyone to this live stream, or whatever this is. And today I'll be focusing on Rust. And this is going to be a workshop. So actually, I should show you bit.ly get rusted. So this is the link to this workshop. And this is happening, this workshop is like happening on Kathmandu University for Kathmandu University students and is organized by Kathmandu University Computer Club. And next thing is, let me just like skim through the goal of this workshop. Okay, first thing is, let's talk about assumptions. The assumption is that you already know how to program basic things. Like you don't need to be very proficient at what you do, but you should be able to grasp the concepts of loop, concepts of if statements, and things like that. Which, if you have this basics covered, then I guess Rust won't be much of a difficult task, like at least understanding the basics of it. Like if you want to go deeper, then it's a different story then. So the goal of the workshop will be to like teach some Rust, its syntax and the language, how well it's built, its features, and what makes it like tick, and why cool people are using it, and how can I start using things like that. Okay, and we can also discuss various resources and provide roadmaps for programmers. Okay, right here in this workshop, and from starting a project to finishing it, what are the tool chains? How do I like write my tests? Or what type of crates or libraries should I use? What are the package managers available to me? These things, right? These things matter. Like even the editor, if there is a code completion or there is a language server for this programming language, like these things makes life easier. Like if you want to debug, then what is the best debugging supporting tool? Like Python has PDB. What does Rust have? Rust also uses GDB, by the way. And now let's talk about embedded systems. So this workshop, right? It's all like build up for actually introducing the concepts of embedded systems and doing Internet of Things, like writing programs for microcontrollers and everything like that. So this workshop is a builder for that. So at the end of the workshop, we will be going through embedded systems and writing some custom embedded code too. And the projects we'll work on, first off, is like we'll be building very simple key value store in Rust. It's going to be a command line application, and that command line application will have as expected, a command line interface. And then you'll also we'll also go through like ESP32 or ESP microcontroller series, and we'll learn to program ESP32 microcontroller, everything from hello world to writing a simple deauthenticator for your wireless 2.4 gigahertz wireless devices, which basically means you will be writing a code and you'll upload it to ESP32, and ESP32 will be like will be able to send like the authentication packets to your computer or router, so that every devices in that vicinity will be denied of the service. So we'll also do that, right? And there are certain projects, so we'll go through like it's going to be a walkthrough for these projects too. Like we'll first look at learning Rust with entirely too many linked lists. So these are not the like we'll not go in very much detail, but I'll like lay out what actually it's trying to convey, and you figure out and understand by yourself, because these topics, right, or these it's a book. Okay, Learning Rust with entirely too many linked lists. If you go through it, it's very concise, it's very beautiful, and there is a lot of things you'll like get by going through it. So but we'll skim through it, like I'll write some code and discuss very important parts or important the things that might topple you off. So these things I'll talk about in this walkthrough projects, and these are already very written, well written blog posts. So assumptions I talked about and covered stuff. We'll talk basic Rust, ownership, and borrow checking. We'll also go through compound data types, pattern matching, standard library, and other things like traits and generics, etc. So guide materials will be provided right here if you go through. And for each week, a task will be given and a learning path. That means there will be things that you have to learn at the end of the week, and those tasks, if you complete, then you'll be like provided with gifts. So it's going to go, how long is it going to go? I guess I'll try to wrap it up within a 1 month time, and given that our exams are in January, we'll have to like basically go fast. So this is the QR for our form or this site. So let's get through the slides. I'll try to be like I'll try to finish these slides within like 30 minutes. So why Rust? All this hype, all these projects, all these rewrites. Like, why are people preferring Rust? And like adaptation rate is very high. Why? So let's go through this. Let me get into the presentation mode. So Rust, why? The topics we're going to cover right in this slide is that I'll try to introduce what Rust is and comparison with C, C++, the big boy language, the bare metal language, the language that defined the era of programming before programming was cool. Okay, so other things that I like to cover are ownership, borrowing, lifetimes, pattern matching. These things, right? We can go through it in detail, and most probably you'll have very hard time understanding them right now. But I guess giving a bird eye view of what these things are, these features, and how these features integrate well to make this a systems programming language, a memory safe language, a concurrently very beautiful language. So these things all work together, right? And to understand those like concepts, or to understand how Rust actually functions, you need to have this understanding of these features. And I'll just skim through it. It's going to be not that detailed actually. So Rust has been most admired language for 2022. Why is that? Not only for 2022, it has been for 2021, 2020, like for the past 5-6 years. One simple reason is that Rust is very elegant. And if you go to Rust website, they advertise it like this: performance, reliability, and productivity. Performance, how does Rust achieve performance? Blazingly fast and memory efficient. Like if you go through like projects in Rust, then blazingly fast is the it's a common word you'll find among those Rust projects. And it goes blazingly fast because essentially what's happening under the hood is that there is no such thing as garbage collector here, or there is no such thing as like interpreted it's not an interpreted language, it's a compiled language, which means it goes down to the bare metal. Before going to bare metal, there is this intermediate layer which we call LLVM, which is basically IR representation, code representation. Before like it goes to the form that your machine can understand, it goes to this middle form, which is intermediate code representation. And that intermediate code representation, which LLVM compiler or LLVM system can actually read it and convert it into the other executables. For example, I'm currently on M1 Mac, but I can build for Intel. How is that possible? Because I just need the compiler for what Intel systems, and I'm good to go. Next thing is I was a bit off of the track, so I like to keep myself in track. from now on. So reliability and productivity. How does Rust achieve reliability and productivity? There are concepts like I just talked about: ownership, borrow system, borrow checker, lifetimes. These things make sure that the Rust is reliable. And there are other semantics, move semantics, things like move semantics and zero cost abstraction. These are the things, these are also the things that makes it very reliable. Talking about productivity, Rust has very good documentation, a friendly compiler with very useful error messages. Many times what you'll find is that people are like appreciating how good the compiler is. It's because the error, they are very informative. Like, it goes to the line, and it also gives you suggestion about what might have gone wrong. And there will be always a detailed some kind of post related to it, like whether in the forum or whether in the Rust documentation itself. So it has a very good integrated package managers. And for productivity or for programmers, one important aspect is good editor support, right? And good package manager. For example, JavaScript has npm or PNPM, whatever new things are coming up on, we don't care. But Rust has integrated one, Cargo. And how capable is Cargo? If you want to like format, right? Like in JavaScript, you have to use something like prettier, right? But Rust FMT is already provided to you. If you want to generate documentation, Rustdoc is already provided to you. If you want to write tests, test is built right in within the system, and these things make you very productive. And there are unique features or very powerful features like macros and other things which make it very, very beautiful language. So what it is, it is used for system programming, that's for sure. And then it targets the same use case as C++. What I'm telling you right now is how the developers initial Rust development was had started, right? For systems programming, because apparently null pointers or nullability, things that go null, it's a $1 billion mistake. Like software companies are hampered by it because something because we allow null. And if you look at the Microsoft and other company reports, then we can see that this memory referencing error, something like segmentation fault and things like that, this has cost companies a lot of things, like their time, their money, their investment, and everything like that. So Rust initially targets to like replace C++ use cases, and it's a compiled language. It compiles down to LLVM, intermediate code representation. Also, it's a statically typed language. By statically typed language, I mean like you have to define what is an integer, the size of integer, for example, I32, it's a 32-bit integer, and whether it's unsigned or signed, which means you can go negative or it's just positive, things like that, right? And it supports many platforms. If you want to get it for Intel, if you want to get it for Mac, if you want to get it for like with WebAssembly, or if you want to like target entirely new chip, for example, RISC-V processors, then it's supported, because ultimately it boils down to LLVM, and whatever LLVM supports, Rust will automatically support. And it can be used in desktop, mobile, routers, servers, whatever you think, right? And the thing is, since most of our attendees, I hope come from this front end background, or at least has dabbled with front end, with such things like libraries like React, maybe Svelte, Vue, something like that, or Flutter. So front end is possible with Rust itself. You can write very performant concurrent code or front end code with features like server-side rendering and everything in between, just from Rust. And this move is quite different, like what this slide initially said. Like I'm saying, this slide says it's for systems programming, but we can also use it for front end. Like the developer productivity in Rust, one downside, I'll say it right now, it's compile times. Other than that, you can do anything in Rust, and it's going to be a very good developer experience too. Like once you understand the basics, then you'll write performant, reliable code. with the code that's deterministic. This type of things that matters, right? It comes with a lot of years of experience, maybe 10, 20 years. But now Rust compiler is forcing you to like write good code. So selling point of Rust, as I've told before, it's a good tooling, right? Very good compiler errors, built-in support for testing. It's the language server protocol is very good, and the package manager called Cargo. It's also very beautiful. Like in a sense that Cargo has integrated everything in itself. You want to write test? There is support for test. You want to benchmark? It got support for benchmark. Like you wanna check for code coverage, let's install tarpaulin, cargo tarpaulin, and it will check for code coverage. These things, they matter, and the tooling is quite good. Language server protocol, if you don't know what it means, it means like when you are using VS Code or editors like NeoVim or Emacs, what's happening under the hood is that those languages, or sorry, those editors are actually calling language server protocols with this interface defined by Microsoft, right? It's interface defined by Microsoft, and all these language follow it, and LSP will give you this code completion, inlay hinting, and things like that. So next thing is memory safety through compiler enforcement. Like compiler uh, is active in finding out if you wrote memory safe code or not. So this is a very tricky thing, and I can't like summarize it in like 5-10 lines. But let's go to this 4 points. Okay, it doesn't permit null pointers at all. So null pointers is not permitted. So next thing is no dangling pointers. Dangling pointers basically means you have a pointer, right? It pointed to something, but now it's pointing to nothing. It's dangling. So the data races in concurrent situation, it's never going to happen because of this Rust primitive concept of ownership, borrowing, and things like that. So let's talk about memory management too. Resources are managed through RAII. What does RAII mean? It's resource acquisition is initialization. Its full form is that. And RAII, when you hear that, it just simply means there are smart pointers being used. Like the definition of stack and heap, if you know about it, like stack is something like you use for code whose the type or the size is already known at the compile time, you use it stack, right? But for box, you or for heap, what you do is you don't know the size at compile time, and it's runtime dependent things. So for the runtime dependent things, you use heap. For example, vector, which is one of these one of the what like one of the storage mechanism in Rust that is actually stored in heap. So next thing is it's time. Is it the time for you to take red pill and explore Rust? Like red pill, blue pill. This actually this matrix reference might actually not be correct just because of color. Like red pill, it means something that's rebellious, something that is a very different light. But Rust is not rebellious. Rust is very beautiful. So here is this hello world program in Rust, and there is another program called FizzBuzz. This is quite a very beautiful interview problem or interview question that are given to this interviewers, given by interviewers. So what you have to do in FizzBuzz is that you have this number 1 to 100, and you are matching if something matches, something is divided by 3 or something is divisible by 5 or not. So once you're checking through it or you are matching through it, so if it's 0 0, which basically means it's divisible by 3 and it's divisible by 5, you are printing FizzBuzz. If it's only divisible by 3, then it's fizz. If it's only divisible by 5, it's you're printing buzz. So it's quite a beautiful code, right? You are not using if case, you are using match. This is something we call pattern matching. So variable assignment in Rust, it's a little bit different. Let me check the time. It's 42. Let's go through variable assignment. So variable assignment, something bad happened. uh, it's actually glitching, which means